In this lesson, I'm going to go over how to use the inscribed quadrilateral theorem. This is going to be part 2 of our video notes on 10.4. All right, so a couple of things here in this first box, looking at an inscribed polygon, which is a polygon whose vertices lie on a circle. So you can see this inscribed polygon in green that I put on there. And then a circumscribed circle would be a circle that contains all the vertices of an inscribed polygon. Now we're going to be using a theorem to do 2 questions in this video, so it'll be a pretty short video. But we're going to use this inscribed quadrilateral theorem, which is a quadrilateral that can be inscribed in a circle if and only if its opposite angles are supplementary. So if you look at this green quadrilateral that I put there, looking at those vertices A, B, C, and D, we are going to say that angle A and angle C add up to 180 degrees, as well as angle B and angle D also add up to 180 degrees. Okay, let's try a couple examples here. All right, so starting with number 15, all right, I see this quadrilateral, so I am going to say that angle X and angle M are going to add up to 180 degrees, as well as angle L and angle N. All right, so I'm going to write those down. So let's do 10x plus 16y plus 6 equals 180 degrees. And then the other one is 4 plus 18y plus 10x minus 6 equals 180 degrees. I'm going to go ahead and move over that 6 to the other side with subtraction to get 174 degrees. This I'm going to rearrange the order to write 10x plus 18y, and let's see if your brain can follow this. I have 4 and a negative 6 on that left side, which is going to combine to negative 2. But when I move that negative 2 to the right side with addition, I'm going to get equals 182 degrees. Now I'm hoping that when we get here, you'll notice that if I have both of these equations, that we can use some of that work that we practiced in the first semester, where we're going to use this as a system of equations, and we can figure out how to solve them using elimination. So I'm actually going to write this one on the right side underneath to write 10x plus 18y equals 182 degrees. I notice that the numbers, the coefficient in front of x for both of these are the same, so I'm going to put subtraction. So I'm going to subtract 10x minus 10x, which is nothing. 16y minus 18y is negative 2y. 174 degrees minus 182 degrees is a negative 8, so y is equal to 4. Now, because it does say to solve for x and y, I do need to plug back in. I'm going to use my original, 10x plus 16y plus 6 equals 180. You could also use one of the ones I highlighted in orange. It doesn't matter. So I'm going to plug in that 4, which gives me 10x plus 64 plus 6 equals 180. So that's going to be moving that over. 64 plus 6 is 70. When you move 70 over with subtraction, you get 110. So x equals 11. So these are the 2 values. Now you could plug those back in to each of these original angles, and you would find that angle L is going to be 110 degrees. So angle N, if I plugged in that 4, would be 70 degrees. And then same thing for angle X and angle M. Angle X is going to be 76 degrees. Angle M is going to be 104 degrees, all right, which both of those pairs are supplementary. Okay, let's do the last one, 16. So same idea here. I've got angle L and angle N are going to be supplementary. Same thing with angle V and angle M. So I'm going to write 7x plus 1 plus 2y plus 74 equals 180 degrees. All right, then I'm going to write 2y plus 100 plus 6x minus 10 equals 180 degrees. All right, go ahead and clean them up a little bit. So this one, I'm going to write 7x plus 2y on the left side. 74 plus 1 is 75. So when I move that 75 over with subtraction, I get 105 degrees. And then on this one, I'm going to write the 6x first, then the 2y. 100 minus 10 is 90. If I move that 90 over subtraction, I get 90 as well. All right, so now I'm going to, like I did in the last one, take this one on the right and move it underneath the one on the left. This is a system. And it worked out well that my coefficients in front of y are the same. So I'm going to use the operation of subtraction to eliminate that variable. So this is going to be x equals 105 minus 90, which is 15. All right, plug into one of your equations. You've got options here. I'll plug into the 7x plus 2y equals 105. So 7 times 15 plus 2y equals 105. So 7 times 15, that's going to be 105. Plus 2y equals 105. Just confirm that. That doesn't seem right. Is that right? No, it is right. Okay. All right, move that 105 over with subtraction. You get 2y equals 0, so y equals 0. Let me check this by plugging it in. I didn't check the last one. So I have 7x plus 1. So I'm going to multiply. Actually, they go back here. There we go. 7 times 15 plus 1. So that's going to be 106. Okay, and then I'm going to have 2 times 0 plus 74, which is 74. Okay, that checks out. Great. All right, have me worried with that 0. All right, and I'll do angle V and M as well. 2 times 0 plus 100 is 100 degrees. Let's make sure this is 80. 6 times 15 minus 10. So that's going to be 90 degrees minus 10 is 80 degrees. All right, we're good. Whew, had me worried there. All right. So again, I've solved for x, solved for y. And the takeaway from this is in using that inscribed quadrilateral theorem for questions 15 and 16, you'll notice we ended up kind of having to review our work with solving a system of linear equations. All right. So if you have any questions with that, try the practice problems. Come see us for help. Good luck.